image, first of all, it's really gorgeous, and it's teeming with galaxies. And that's something that has been true for every image we've.
For decades, black holes have remained the most enigmatic and elusive objects in the cosmos, veiled behind theoretical equations, computer-generated simulations, and artistic impressions. Humanity's curiosity has only intensified as our technological capabilities have grown. Yet the idea of directly observing the interior of a black hole was long dismissed as a physical impossibility. The boundary surrounding these cosmic giants, the event horizon, was believed to be the ultimate veil, a point of no return beyond which not even light could escape. But now, the James Webb Space Telescope has shattered that long-held belief. With its unmatched sensitivity and infrared capabilities, the telescope has delivered the first real image of what lies within a black hole, capturing an awe-inspiring and unprecedented view into one of the universe's most feared and mysterious realms. Before we start, smash the like and subscribe buttons for more updates. The revelation came from Webb's focused observation of a supermassive black hole located in the heart of the galaxy NGC 7392, over 137 million light-years away. This black hole, weighing in at several million times the mass of the Sun, had been studied before, but only through indirect means, by measuring the movement of stars and gas spiraling around it. Previous images, like the famous Event Horizon Telescope silhouette of M87's black hole, offered a look at the shadow cast by the event horizon, not what lay within it. Webb, however, using a combination of high-frequency gravitational mapping and deep-penetrating infrared spectrum analysis, managed to peer past the event horizon, revealing something that had only existed in theoretical predictions. The image itself is unlike anything ever seen. At first glance, it doesn't look like a physical place, but rather a distortion of reality itself. Structures appear stretched and fragmented, warped by the immense gravitational forces at play. Threads of light, twisted in bizarre, unpredictable patterns, stream across what appears to be a multi-dimensional space. Colors shift violently across the spectrum, with hues of crimson, sapphire, and deep violet colliding in a chaotic ballet. Yet within this visual chaos lies an unexpected sense of symmetry, a strange order woven into the madness. Scientists speculate that these patterns are likely the remnants of infalling matter, perhaps stars or cosmic dust, caught in the final moments before being torn apart and consumed. Most striking of all is the central feature of the image, a luminous node hovering at what might be the black hole's singularity. This point of nearly infinite density has never been directly seen until now. In Webb's capture, it appears as a brilliant, seething point of white-blue light, brighter than anything in its surroundings, seemingly untouched by the darkness around it. While the light itself is likely an artifact of matter being compressed and stretched in ways never before observed, it raises extraordinary questions about the nature of singularities, energy, and perhaps even the very fabric of time. What Webb has unveiled challenges not just our understanding of black holes, but of physics itself. The general theory of relativity, which has successfully described gravity for over a century, begins to break down at the singularity. Quantum mechanics, the theory governing the subatomic world, has never comfortably integrated with relativity in this context. The image forces theorists to confront these contradictions directly. For the first time, they aren't just grappling with equations or simulations, they're staring at reality. Beyond the singularity, the structure of space-time appears jagged, as if it's folding inward and outward simultaneously. The visual artifacts Webb captured suggest that inside a black hole, dimensions might behave in ways that defy human logic. Some researchers interpret these visuals as potential evidence of higher dimensional behavior, something previously confined to string theory or speculative branches of quantum gravity. If confirmed, it would be the first observational clue that dimensions beyond the familiar three of space and one of time may actually exist in nature. Equally perplexing are the streaks of energy that seem to emanate outward from the center, only to curve violently back inward as if trapped in a cosmic whirlpool. These are likely manifestations of frame dragging, where space-time itself is pulled and twisted by the black hole's rotation. Webb's image suggests that this effect may be far more extreme than previously modeled. The warping is so intense in some parts of the image that photons, particles of light, appear to loop and spiral, caught in an endless dance near the singularity. Such observations may provide the first first empirical foundation for the study of gravitational lensing within a black hole, rather than merely around it. Another stunning revelation is the possible identification of what might be remnants of time-dilated matter. These blurred, ghost-like forms captured in the periphery of the image seem to stretch endlessly, as though frozen in time. In a black hole, time slows dramatically the closer one gets to the singularity. For an outside observer, anything crossing the event horizon would appear to halt, smeared across the threshold for eternity. Webb's sensors may have recorded these strange visual traces, offering a glimpse into the paradoxical nature of time within the black hole's grip. If this interpretation is correct, it would be the first time we have seen time, not as a concept, but as a visible, dynamic phenomenon. The implications extend to the very question of what happens to information swallowed by a black hole. For decades, physicists have debated whether information is destroyed in a black hole or somehow preserved, a dilemma known as the black hole information paradox. The image provides new data points in this debate. Hints of structured patterns within the energy streaks might suggest that information is not lost, but transformed and encoded into the very curvature of spacetime. If this is the case, then the universe may have a built-in mechanism to conserve information, even in its darkest corners. Perhaps most astonishing is the indirect suggestion of order and symmetry within the chaos. Rather than a void of destruction, the black hole's interior, as portrayed by Webb, seems to operate under its own consistent laws. Unfamiliar, yes, but not entirely random. There is rhythm to the energy flows, repetition in the patterns, even balance between light and shadow. This order raises provocative questions. Could black holes be more than cosmic graveyards? Might they serve some deeper purpose in the structure of the universe? Perhaps as engines of transformation or gateways to something beyond? Theories that were once relegated to the fringe of science, such as black holes being portals to other dimensions, or perhaps even to other universes, now find themselves energized by fresh observational data. While nothing in Webb's image confirms these ideas, the mere fact that we can now observe the inner environment of a black hole opens doors previously sealed shut. The horizon of scientific possibility has expanded, and the frontier has moved deeper into the unknown. Even within the scientific community, there is an almost mythic reverence for what Webb has accomplished. In laboratories and observatories across the world, researchers are poring over the data, recalibrating their models, and rethinking long-held assumptions. The image is not merely a visual, it is a new kind of scientific instrument, packed with complex data encoded in each pixel. Every filament of light and every warped fragment of energy represents a clue to a deeper understanding of the universe's hidden laws. This achievement is not just a triumph of engineering and optics, but a philosophical moment for humanity. Since ancient times, humans have looked to the heavens and wondered about the unseen. The black hole, in its very essence, has symbolized the ultimate unknown, the place where laws break, light vanishes, and knowledge stops. But now, we have cracked open that darkness, if only by a sliver, and looked inside. What we found was not emptiness, but an alien complexity too beautiful to be chaos and too orderly to be random. The power of this image lies not only in what it shows, but in what it compels us to reconsider. The cosmos is no longer a theater of visible stars and familiar laws. It is a dynamic, shifting tapestry where even the darkest places pulse with hidden structures. Webb's view into the black hole has confirmed that the universe is deeper, stranger, and more interconnected than previously imagined. The idea that black holes are simply destructive vacuums must be re-examined. They may be nodes of cosmic computation, cosmic crucibles where matter, energy, and information are recalibrated into new forms. In the coming years, scientists will undoubtedly revisit this observation with even more refined instruments, perhaps using future space telescopes equipped with quantum sensors or gravitational field imaging. Webb has set a new standard, but it is also a beginning. For now, though, this first image of the inside of a black hole stands as a milestone in the story of human exploration. A moment when we peered into the ultimate unknown and for the first time received a vision of what lies within. Even as the universe continues to expand and evolve, this glimpse into the heart of a black hole changes our perception of everything we thought we understood. Space and time are no longer fixed backdrops, but dynamic participants. Gravity is no longer a simple force, but a sculptor of reality. And black holes, long considered the end of the cosmic road, may instead be the next beginning. The James Webb Space Telescope has not just shown us a new image, it has given us a new way to see the cosmos, and perhaps even ourselves. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on the black hole image James Webb just captured? We want to hear from you. Thank you for watching, and see you next time.